Hello everyone, today I'm going to explain what is interquartile range. So what is interquartile range? The interquartile range or IQR measure the spread of the middle half of your data. It is the range for the middle 50% of your sample. The first quartile, denoted Q1, is the value in the dataset that holds 25% of the values below it. The third quartile, denoted Q3, is the value in the dataset that holds 25% of the values above it. The formula for finding the interquartile range is IQR equal Q3 minus Q1. Equivalently, the interquartile range is the region between the 75th and 25th percentile, or 75 minus 25 equal 50% of the data. Next, what is the interquartile range used for? IQR is used to measure how spread out the data points in a set are from the mean of the dataset. The higher the IQR, the more spread out the data points. In contrast, the smaller the IQR, the more bunched up the data points are around the mean. The IQR range is one of many measurements used to measure how spread out the data points in dataset are. It is best used with other measurements such as the median and total range to build a complete picture of a dataset's tendency to cluster around its mean. Next, how to determine IQR. Method number 1 is understanding the IQR. Step 1. Understand how to use IQR. Basically, IQR is a way of understanding the spread of a set of numbers. The root quartile range is defined as the difference between the upper quartiles, 25% top, and the lower quartile, 25% lowest of the data set. Step 2. Understand quartiles. To illustrate quartiles, divide the set of numbers into 4 equal parts. Each of these parts is a quartile. Suppose the data sets are 1, 2, 3, 4, 5, 6, 7, and 8. So 1 and 2 are the first quartile or Q1, 3 and 4 are the second quartile or Q2, 5 and 6 are the third quartile or Q3, and 7 and 8 are the fourth quartile or Q4. Step 3. Learn the formula. To find the difference between the upper and lower quartile, you must subtract the 75th percentile from the 25th percentile. Method number 2 is compiling the data sets. Step 1. Collect your data. If you study IQR in class and in test, you may be given a set of data already prepared. For example, 1, 4, 5, 7, and 10. This is your data set, the number you will work with. However, you can build your own number from table question or story problem. Step 2. Sort your data in ascending order. In other words, arrange the number from smallest to largest. Use the hints from the following example. Example of even number data, set A is 4, 7, 9, 11, 12, and 20. And the example of odd number data in set B is 5, 8, 10, 10, 15, 18, and 23. Step 3 is divide the data in half. To half, find the midpoint of your data, the number or numbers that are in the very center of the data set. If you have an odd number of data, choose the number that is right in the middle. If you have an even number of data, the midpoint is between the two most middle numbers. Method number 3 is calculating the IQR. Step 1. Find the median of the lower and upper half of the data. The median is the middle point, or number that is in the middle of the set or numbers. In this case, you are not looking for the midpoint of all the numbers, but are looking for the relative midpoints of the upper and lower data subsets. if you have an odd number of data, then include the middle number. Step 2. Subtract the Q3 minus Q1 to determine the IQR. Now you know how many numbers fall between the 25th and 75th percentile. You can use this number to understand the spread of the data. For example, if test has a maximum score of 100 and the IQR of the score is 5, you can assume that most people taking the test will have almost the same understanding because the range of highs and lows is not very large. Next, how do you find the IQR? Step 1. Order the data. In order to calculate the IQR, we need to begin by ordering the values of the dataset from the least to the greatest. Likewise, in order to calculate the median, we need to arrange the number in ascending order from the least to the greatest. Let's sort an example dataset with an odd number of values into ascending order. The dataset is 9, 3, 2, 5, 6, 11, 4, 3, and 2. And odd dataset that already ascending is 2, 2, 3, 3, 4, 5, 6, 9, and 11. Now let's perform this test with another example dataset that is comprised of an even number of values. The even dataset is 11, 2, 4, 3, 8, 1, 2, 7, 4, and 9. If we arrange into ascending order, it will become 1, 2, 2, 3, 4, 4, 7, 8, 9, and 11. Step 2. Calculate the median. Next, we need to calculate the median. The median is the center of the data. If a data set has an odd number of data points, then the mean is the centermost number. On the other hand, if the data set has an even number of values, then we will need to take the arithmetic average of the two centermost values. We will calculate this average by adding the two numbers together and then dividing that number by 2. First, we will find the median of a set with an odd number of values, crossed out until we find the centermost point. The median of the odd valued data set above is 4. Now let's find the mean of the data set with an even number of values. Cross out values until you find the two centermost point and then calculate the average of the two values. Find the average of the two centermost values is 4 plus 4 divided by 2 equal 8. 8 divided by 2, and the median of the even value set is 4. Step number 3. Upper and lower medians. Once we have found the median of the entire set, we can find the medians of the upper and lower portion of the data. If the data set has an odd number of values, we will omit the median or centermost value of the set. Afterwards, we will find the individual medians for the upper and lower portion of the data. Find the median in the lower portion. The odd data set is 2, 2, 3, 3, 5, 6, 9, and 11. Calculate the average of the two values. Average equal 2 plus 3 divided by 2 equal 5 divided by 2, and the median of lower portion is 2.5. Find the median in the lower portion. The odd data set is 2, 2, 3, 3, 5, 6, 9, and 11. Calculate the average of the two values. Average is 6 plus 9 divided by 2 equals 15 divided by 2, and the median of the upper portion is 7.5. Step 4. Calculate the difference. Last, we need to calculate the difference of the upper and lower medians by subtracting the lower median from the upper median. This value equals the IQR. Let's find the IQR of the odd dataset. IQR of the odd dataset is 7.5 minus 2.5, so the IQR is 5. Question: determine the interquartile range value for the first 10 prime numbers. Solution: the first 10 prime number are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So the number of value is 10. 10 is an even number, therefore the median is mean of 11 and 13, that is Q2 equal 11 plus 13 divided by 2 equal 24 divided by 2. The result is 12. Q1 part is 2, 3, 5, 7, and 11. Here the number of the value is 5. 5 is an odd number, therefore the center value is 5, that is Q1 equal 5. Q3 part is 13, 17, 19, 23, and 29. Here's the number of value 5. 5 is an odd number, therefore the center value is 19, that is Q3 equal 19. The subtraction of Q1 and Q3 value is 19 minus 5 equal 11. Therefore 11 is the interquartile range value. Using box plot to graph the interquartile range. This graph displays the range of values based on quartiles and show asterisks for outliers that fall outside the whiskers. Box plots work by splitting your data into quartiles. The box in the box plot in your interquartile range that contains 50% of your data. By comparing the size of these boxes, you can understand your data's variability. More dispersed distribution has wider boxes. If the median is closer to one side or the other of the box, it's a skewed distribution. When the median is near the center, your distribution is symmetric. How to Step 1. Find the Q1. Q1 is represented by the left-hand edge of the box at the point where the whisker stops. In the above graph, Q1 is approximately at 2.6. Step 2. Find Q3. Q3 is represented on a box plot by the right-hand edge of the box. Q3 is approximately 12 in this graph. Step 3. Subtract the number you found in step 1 from the number you found in step 3. This will give you the interquartile range is 12 minus 2.6 is